Hi, and thanks for staying at this late hour. My name is Tomer Handelman. I've been a data scientist for the last 6 years, and for the last year and a half, I've been working at PayPal. And today I'm going to talk to you about business to VAC, which is utilizing behavioral data to meet our customers' needs. Okay, so I assume that many of you have used PayPal in the past in order to perform online payments. What most of you probably don't know is that PayPal offers its customers a large variety of other financial products besides the ability to pay online. For example, PayPal offers you a warranty for each transaction that you perform online. If something goes wrong with this transaction, if, for example, you didn't get the item that you ordered or you got something different than what you ordered, PayPal will give you your money back. In addition, we provide business loans, and another example here is you can see the physical device called PayPal here, which allows a business to accept physical credit cards. Okay, so I'm part of the data science group inside PayPal. Basically, our job is to help PayPal meet our customers' needs in the best way possible. In order to do so, we first need to have a very good understanding of what are our customers' needs. One of the basic features that you want to understand about a business customer is what is the business selling. As you can see here, we serve a very large variety of industries. For example, food stores, streaming services such as Netflix, or an ordinary site, online site selling sandals. Each of these industries, they have different needs. For example, offering a streaming service like Netflix, the device PayPal here that I showed you earlier might not be a good idea because they're not a physical business. And in addition, if you think about it, if you order a hamburger, most chances are that you will get this hamburger. However, if you will order a pair of sandals from the online store on the left, the chances are, Dor Israel. Okay, so now that we all agree that understanding the industry of the business is very important for us, how can we try and figure out what the industry of the business is? So if we examine the website on the left here, it's pretty clear that he's selling sandals. He's in the fashion business. We can see some clear indications in the URL, in the business name, and in the images, in the description. It's pretty easy to figure it out. Okay, so it's very easy to figure out what a business is selling, and the problem is solved, right? We can all go home. Well, not quite. As we all know, a data scientist's job is never that easy. What can we do in this example, for example? It's like the 20th time that I've watched this website, and I still don't know what this guy is selling. It's not very clear, not from the URL, not from the images. It's not very clear. And many businesses, they don't even have a website. So how can we identify the industry without any clear signals if we don't have a website or if the website isn't really telling us anything? Okay, so as data scientists, we all know that behavioral data contains a lot of information. So we thought to look for the answers there. Okay, so here is my shopping history. As you can see, I have a very large interest in watches. So on January, I bought something from David Watches Store. On March, I bought something from Moshe's Watches Store. And on May, I bought something from Chaim's Watches Store. All of them belong to our fashion stores. And on July, I bought something from Ronnie's store. And we don't know which industry Ronnie's store belongs to. So what we can see here that maybe we can somehow identify that because I have a very large interest in fashion stores, it somehow increases the probability that Ronnie's store is also selling fashion. If we see many such sequences, it can provide us strong indications that Ronnie is indeed selling fashion. Okay, so basically we have many, obviously I'm not the only person buying stuff on PayPal, so we have many such buying sequences. And then we wanted to try and gain insights regarding the businesses from these sequences. So due to the sequential nature of the data, it seemed very natural to use an algorithm from the domain of NLP, natural language processing. Because in NLP, well, you know, a language is basically large. It's composed of large amount of sequential data. Okay, so we chose to use word2vec. I assume that most of you are familiar with word2vec. Basically, what word2vec does is it accepts a large list of paragraphs, and from for each word that appears in these paragraphs, word2vec creates something called a word embedding, which is a vector in some n-dimensional space that represents this word. The way that word2vec learns how to do this mapping is according to the context in which the word appears. So for example, as we see in the example here, baking and cooking, they tend to appear in similar contexts, so their vectors will be mapped to locations close to each other in space. Same goes for truck and car. Okay, so how do we apply word2vec on our behavioral data? So once again, in addition to my interest in watches, I'm also interested in other fashion stores. We see here that I bought something from ASOS, afterwards I bought something from Next, and afterwards I bought something from Zara. So basically we take this buying sequence and we create out of it a paragraph saying ASOS, Next, Zara. It's like a textual paragraph. And here we see this other guy, he bought something from ASOS, afterwards he bought something from John's Business, and afterwards something from Zara, and again we create a paragraph for him. And then we give all these paragraphs to word2vec and create a vector representation for each business. What we hope to see here is that because Next appears in the context of Zara and ASOS, and John's Business also appear in the context of Zara and ASOS, hopefully, if given enough such appearances, John's Business and Next will be mapped to locations close to each other in space. And then we'll be able to deduce that John's Business is also selling fashion. Okay, so let's look at, so we perform this mapping of the businesses. And then here, what we see here is that we try to, basically we try to predict the industry of each business solely based on the data that we learned from the behavioral buying sequences. And we use the classifier k nearest neighbors. It's a very simple classifier. Basically what it does, it looks at the k nearest vectors closest to you in space, and it assigns the item with the label that the majority of them have. So here we see the F1 scores for different industries. And it's quite interesting. We can see that for some industries like automotive parts, clothing stores, and stamp and coin, we have very good performance. And for food stores, we have very poor performance. Actually, the most impressive one here is, the most impressive bar here is stamp and coin, because as you can imagine, it's not a very, the problem here is a bit more difficult because it's not a very common industry. Okay, so let's take a closer look at this phenomenon. Here we see we reduced the dimensionality of the vectors into 3D using PCA. And again, we can see that for automotive parts, all the vectors are very tightly clustered in one part of space. And for stamp and coin, I'm not sure if you can see it, but it's sort of, all of them are sort of on the floor. And for food stores, they're a lot more scattered in space. One sec. Okay, if you still don't believe me, here is a more mathematical measurement. Here we measure the silhouette score in order to check the quality of the different clusters of the industries. Silhouette is a measure that what it does, it compares for each point inside the cluster, it compares the average of the distances from the point to other points inside the cluster, and it compares it to the distances to the point in the to all the points in the cluster nearest to this cluster. So it checks both. It validates that the cluster is compact and that it's separated from other clusters. So in this example, cluster number 1 will have a higher silhouette than cluster number 0 because it's more compact. So once again, we see that stamp and coin got the highest silhouette score, and automotive parts second, and food store got very poor silhouette score. Okay, so now that we all agree that some industries are better have a much better clustering than others, much better clusters. Let's try and understand why are we observing this phenomenon. So here we can see 2 buying sequences for each industry, for stamp and coin and for food stores. It's pretty obvious here that people who buy stamp and coin are a lot more persistent with their buying sequences. And people that buy food stores, they have a very large variety of other industries in their sequences. If you think about it, it makes perfect sense because, well, we all buy food, and people that buy stamp and coin, there are people that have a very unique interest in stamp and coin, so it affects all their buying activity. Okay, once again, let's look at a more mathematical measurement for this result. So here we measure the PMI, or point-wise mutual information. It's also something commonly used in the field of NLP. Basically, what PMI does, it compares the probability of 2 events happening together to what we expect, to the probability that we expect for them to happen together if they're completely uncorrelated, independent. You can sort of think of it as a measure of a correlation between 2 events. In NLP, it's used for basically you measure how much 2 words appear in the same sentence more than you expect them to appear at random. So for each industry, we calculated the maximum PMI, which is we compared it to all the other industries, including itself, and we calculated the PMI value for each such pair, and we took the maximum value. So again, we can see here that stamp and coin got maximum PMI with itself, which makes perfect sense according to the sequences that we saw earlier. And it was very high PMI. And food stores, we got a low PMI with closing stores. What this tells us is basically that the amount of information that you can learn about stamp and coin from the presence of other industries in the sequence is a lot higher than what you can learn about food stores. Okay, so a recap. We saw that word2vec proved to be very useful for behavioral data. What made it handy was probably the sequential nature of our data, and it's probably applicable in other areas that are not e-commerce, where sequential data is present. And my take-home message is you should be brave with your data and try to experiment with it in creative ways. And wait, that's it. Yeah, thank you.